Hello everybody, welcome back. I'm going to do a little task here about a canoe trip, okay, using functions. Mike likes to canoe. He can paddle 150 feet per minute, so this is important information, 150 feet per minute. He is planning a river trip that will take him to his destination about 30,000 feet upstream. That is against the current. Alright, I like to draw a picture at this point. So here's the current going downstream. He's taking his boat against the current. Alright. The speed of the current will work against the speed of that he can paddle. Yeah, that's obvious. Okay. Now, part A. Let S be the speed of the current. Alright, so S is the speed of the current in feet per minute. Write an expression for R of S, the speed at which Mike is moving relative to the riverbank. So he's probably going, oh, I actually gave that right. He's going 150 feet per minute. So his speed relative to the riverbank, he's going to go 150 minus the speed of the current, right? Yeah, that's what R of S is. So R of S is the rate relative to the riverbank, would be 150 minus S. Okay, part B. Mike wants to know how long it will take him to travel 30,000 feet upstream. Write an expression for T of S, the time in minutes it will take in terms of S. So the time it would take to go 30,000 feet upstream. So we have to use this formula. Distance is equal to the rate times the time. So if if the distance is 30,000 and the rate is going to be R of S and the time T of S, so I would divide both sides by R of S. So my function T of S would be equal to 30,000 divided by the rate, 150 minus S. Okay, makes sense. What is the vertical intercept of T? Vertical intercept of T. What does the point represent in terms of Mike's canoe trip? Vertical intercept of T. So when S is equal to 0, right? So this is S, this is our input, and this is our output, T of S. So when S is equal to 0, that goes away, and I just get 30,000 divided by 150. So that means when the water is still, right? So S represents the speed of the current against him. So when S is equal to 0, that means it's just still water, and he can just travel at 150. So it would just be 30,000 divided by 150. And I'll use my calculator for that to save time. So 200. So that would be the vertical intercept at 200. Okay, and then as the speed increases, it will take him more time. So I expect it would be increasing. So that's one thing I say about. Okay. Next question. At what value of S does the graph have a vertical asymptote? Explain why this makes sense in the situation. So when does this go to where his time would be impossible, right? Well, when the speed of the current would go to 150, right? He would just be sitting in place and never moving forward. So that would he would never reach his destination. It would be an infinite amount of time, and he would never get to his destination. So that would be at 150, right? So I expect it would shoot up to infinity, close to 150, right? And that's when you divide by 0, right? 30,000 divided by 0. So that's my explanation is that when it reaches 150 feet per second, he's not moving anywhere, and it's the same as dividing by 0 in the function. For what values of s does t of s make sense in the context of the problem? Well, it should be greater than 0, right? So this is kind of like, what is the domain of s? So I would say the domain that makes sense would be, it'd have to be greater than 0, because if he was going with the current, then it would have been worded differently, right? Or if it was, so it's greater than 0. So we'll say it's between 0 and 150. Well, couldn't be equal to, so I'll just say less than 150. So the domain is s is between 0 and 150. And if it's getting close to 150, then it kind of doesn't make sense, because it might take his whole lifetime if it's like 149.9, right? So to make general sense, I would say like probably less than 100, so that he can make it within a day, you know. Okay, so that's my answer to that question. You are going to be given another variation on the same problem, so I've done a little bit of the work for you, but it's worded a little bit differently, so you can try to pick through the problem in a different way.